Hi guys, this is Miss Raina here to talk to you today about work, power, and energy. Take out the handout that I gave you guys. It says guided notes, work, power, and energy, and we're going to start on the side called work. Alright, so first question, what's work? Right next to your definition, write down it's the transfer of energy by a force. So we're going to have to remember what we learned in forces. The only way that energy is transferred by a force is if it's traveled a certain distance. So in your equations box, write down that work, big W for work, equals F times D, or the words work equals force times distance. So in order to transfer energy by a force, there has to be motion. So there has to be displacement, and the force has to be pushing in the same direction as the displacement. So let's say I lift a kitten up. Then I'm working against the kitten's weight, and my force that I'm applying is in the same direction that I'm moving the kitten. Well, what if I carry the kitten from one side of the room to the other side of the room? I'm not working against its weight, and I haven't applied a force in the same direction that the weight is going against. And so in that case, in physics terms, I'm not doing any work. Alright, so we measure force in newtons, we measure distance in meters. In order to measure work, we use this thing called a joule, and you should write down what a joule is. So if I do a newton times a meter to get a joule, if I do a newton times a meter to get a joule, and a newton is a kilogram meter per second squared times a meter, that gives me a kilogram meter squared per second squared. To abbreviate that, we use a joule, or you can write down just like 1J. Okay, so let's move on to power. It's defined as the rate at which work is done by a force. And so if you want to know how powerful you are, then you need to check out how much work can you do in a certain amount of time. If this is a short time, well, then you've done the work quickly. It means you're powerful. If this is a lot of work, then you've done the work really efficiently, then you're really, really, really powerful. And so you want a short time and you want a lot of work done here, and that tells you how powerful you are. Okay, so write this down under part C. This is how you figure out power in terms of force. So if we know that work is force times distance, and we know that power is work over time, then one option you can use to calculate power is to take your force times distance divided by your time. There's quite a few units we use to measure power, and so first one is the watt. I warned you about the capital letters, right? But there it is. So big W might say you have, like, I don't know, a 60 watt light bulb, and that's the measure of power. You might have a, I don't know, 120 kilowatt I don't know, engine or something like that, or you might have, I don't know anything about cars, but you might have like a 200 horsepower car. And what does a horsepower mean? Well, there's a little bit of a story behind this. The SI unit for power is the watt. That means this is the unit that we're going to be using in physics class. It was named after a guy named James Watt. He invented the modern steam engine. So here's the story. A long time ago, this guy named Watt made something called a steam engine, and the whole point of a steam engine was to lift the coal up from under the coal mine. What they used to do before that is, if the coal mine was like way down here, then they used to have horses way down there, and the horses would pull and pull and pull and pull and pull. They would walk on these pulleys and pull and pull and pull until by ropes there would go the coal up on a pulley like that. The horses were bred to be little tiny things, and so a horsepower is actually the power of 2 ponies. It was much more efficient, and I think much more humane to use a steam engine. Yeah, so here's how it worked. Here's the horse, and if the horse was pretty strong, then it could lift about 150 pounds of coal 220 feet in 1 minute. So Watt decided that this was going to be the power of 1 horse. Make sure you write this down. We don't have a conversion or a flip chart in here anymore, but you can write it down in your margin. 1 watt is 1 joule per second, and 1 horsepower is 746 watts. So let's take an example. Here's a sled. She pulls the sled across the level snow with a force of 520 newtons. So there's our first given. She uses a rope that's horizontal with the ground. Okay, so that means if her displacement is this way, then the force that she's applying is also that way. That's important because that's the only way that you know that work is actually being done. So let's check and see. We've got a distance of 60 meters, and our job is to figure out how much work does Lauren do. Okay, so let's lay this out. I know my force is 520 newtons. I know that the distance traveled is 60 meters, and I've checked this ahead of time. The force and the distance are going in the same direction. I'm supposed to figure out what is the amount of work. And work is not in watts, work is in joules, so be aware of that. The W for work is different from the W for watts. Okay, so now the marker decided to work. I'm going to use that equation, ignore that. I'm going to use the equation I had before. Work is just force times distance. And now it's just easy. All I have to do is multiply. So I need to multiply 520 newtons times 60 meters. At this point, go ahead and pause your video so you can see, punch it in the calculator and see what the answer is. All right. I should have pointed out the answer has been down here the whole time. So if you've got 31,200 joules, then you got it right. And pay attention to your unit right here. Your work, not the watts, your work is 31,200 joules. Power is in watts. And so if the letter comes after the measurement, then this letter stands for a unit of measurement. If the letter comes before the equal sign, then the letter is a variable, and it stands for the type of quantity. So here's the Hulk, and the Hulk really tried hard to lift this heavy bundle way up here. So here's the direction of the force he's applying, and he's going to walk all the way across the room that way. Here's the direction of his displacement, and so your job is to figure out how much work does the Hulk do if he walks that far with a heavy object at a constant velocity. No math allowed. You should know right away this answer is 0, but don't tell him. You don't have to get angry, and you wouldn't like him when he's angry. Next time question, think about why this would be 0, and I'm going to go ahead and cut the video right here. Thank you very much for hanging out with me through another edition of Work, Power, and Energy with me, Miss Raina, here in C347. Bye, guys.